We are now, sorry. So, for those of you watching at home, maybe, we are videoing. To be continued, we had this really random discussion you just asked for. We'll give you the footnotes later. In the name of the Father, and of the Son, and of the Holy Spirit. Saint Michael the Archangel, defend us now. Be our safeguard against the wickedness and snares of the devil. May God rebuke him when he prayer. And do thou, O Prince of the heavenly host, by the power of God, cast into hell Satan and all these spirits who prowl about the world seeking the ruin of souls. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. I meant cliff notes. Footnotes you didn't know six and everything. Anyway,
We know what you meant.
all right. I have a sort of an exotic. Oh yeah, we do have to go through the homework in a second. The one problem, the tree substitution problem. But just you don't have to write this down yet. But one of the more exotic things we've gone through is called repeated integration by parts. And sometimes it is called cyclic integration by parts. I'll tell you what I mean in a moment. I'll just keep you in suspense for a little bit. So let's jump to the homework, the trig substitution, and see how it works. The final answer should have x's in it. So if you still have thetas, you need to back substitute. Let's see what we got. This is not going to take very long once I actually.
What?
Where's it? Oh, here it is.
It's the truth, isn't it?
It is, drum roll please, fraction, x on top, radical x squared plus 1 on the bottom. Plus
Let's see,
c
just bam.
I just flipped it.
Got you.
That's not fun.
Well,
Any repeats?
it's pretty close, okay?
So x on top, radical with an x squared plus 1, and then a plus c afterwards.
Wait, I'm confused.
So,
I'm confused.
so which of these would you like to go over? He asked.
2.
Awesome. Number 2, done. Doesn't exist.
Just ask
We
the
didn't have
question.
anything to go over.
We just ask the question.
Okay.
We don't need to waste time in class when I literally only made one time a year, so.
Somebody else want to see it?
Well, Ellen and I took a while, like, to do it, we did it multiple ways. We had to actually.
This is what they pay me for, so I have no
I mean,
problem.
you
with
could
it.
do it.
So we pay for it.
Well, yeah, you know,
Oh, no.
get your money's worth.
Yeah, okay, do it.
I can't
Sure,
tap
we'll get our money's
dance.
worth.
Please.
So it's, yeah.
Is it
It's a
sine
business.
opposite of the? I guess it's just the inverse sine.
It's a weird interaction.
So radical,
Cos over.
or integral rather,
What?
1 over parentheses, I think it was x squared plus 1 to the 3 n.
Beautiful. Because yesterday we were talking about rules.
Yeah, about
Yeah, right.
She was like, look at my name.
Now,
oh.
I said, okay.
this is a trig substitution problem. What does this kind of remind you of? And again, this sort of, if this were not to the 3 halves, what would you call it? What, does that look familiar? That's inverse tangent.
Yeah.
But it's not, so we need to do a back trig substitution. What x do you think might work for this? Tangent. The reason is that if you have tangent squared plus 1, that's one of the master formulas.
Oh, yeah.
Tangent squared plus 1 is really equal to secant squared, which simplifies. So hopefully that'll simplify it somehow. So if I get this, now, by the way, what's dx? Yeah, secant squared of theta d theta. Okay, so birds apart. I need to transform everything in here. So it looks like I keep saying radical. Integral of 1 over tangent squared of theta plus 1 to the 3 halves times secant squared of theta d theta. So is it with me? Okay. This thing here, I'm going to rewrite as amps power is something radical something. So it's tangent square root of theta plus 1. Tangent square root of theta plus 1 of the radical as well. And then times secant square root of theta. Now we can start, I'd love to do an integration, but I have no idea. These simplify. What is tangent squared plus 1?
Secant squared?
Secant squared.
What?
You still got it.
I got one tiny thing.
But I got it right.
I was telling them to do that the entire time, and they're all like, no, there's no way.
Okay, because
Yeah.
there's something that's,
Yeah, I just mixed up the.
but something that's simple. There's actually two things that simplify right away.
Yeah, the squared and like root thing.
Yeah.
Squared and the root thing.
And the root
Wait a
thing.
minute.
What's the radical of secant squared?
Secant of theta.
Yeah, secant of theta. Now, there's a little bit of a qualification here, but we have to make sure that secant is not negative. But if it were negative, the thing would choke anyway. It would go imaginary on you. So, you remember, technically radical x squared is absolute value of x. And the only time you can drop the absolute values is if x is guaranteed to be positive.
Pretty much.
But if it's not positive, you'd be having an imaginary answer anyway.
Right.
So, not to worry. So, for the purposes of this, you can assume this is fine. So it looks like this now. The integral of 1 over secant of theta d theta. What is 1 over secant?
Wait,
Sine.
Cosine.
Cosine.
Cosine. Hopefully that looks familiar.
Yeah. Sine.
It's sine of theta plus c. Now that's lovely, and it's a very, very nice small answer, but I don't want theta in my final answer. I want x.
Substitute back. Get theta by
Substitute
itself.
back. So what is theta?
Inverse tangent of x.
It's the inverse tangent of x, correct. So now plug that back in. It's the sine of the inverse tangent of x. And that looks like a forward-backward problem. Plus c, right.
That stinks.
So this is x over 1. How do you do a forward-backward problem? So which one? Do a right triangle. So, okay, here's theta. So where do I put these things?
What?
Opposite over adjacent. So x is opposite, 1 is adjacent. Can anybody tell me this thing?
Radical x squared plus 1.
Yeah, radical x squared plus 1 squared, which is radical x squared plus 1. And you could do 1 plus x squared, it doesn't make any difference. So, find the sine of that.
X over radical x squared plus 1.
X over radical x squared plus 1 plus c. In calculus, you do not have to get the radical out of it. So that. Question? Ta-da. No. Are you okay with that? Think you could do that on time?
Hopefully.
The 3 over 2 part time, like if I hadn't had this,
Uh,
I probably wouldn't have known what to do with that.
okay.
Yeah.
Does anybody know what this is? Using the same hint?
X squared
Use
times radical x.
use.
X squared radical x. You can do that with pretty much any, something over 2 power. You can split off like a whole number of x's and then leave the radical. Okay. Oh, here we go. Just a second. So,
He's back. In better shoes.
the integral of sine squared, we have an immediate problem. I know how to do the integral of secant squared, it comes from tangent. I know how to do negative cosecant squared, it comes from cotangent. We've never run into integral of sine squared before. So, how do you do it? There are actually at least 2 ways to do this. One is if you remember some trig formulas that are more exotic. you remember that absolutely beastly problem that I dragged you through where we were transforming cosine squared into 1 minus cosine of 2 theta, well, something horrendous. But dropping the power. Theoretically, you could do it that way.
Could we do like?
I'm gonna show you another way.
Could we do like 1 over cosecant squared? Maybe?
1 over cosecant squared, you could,
I don't know if that works.
but the fact that the cosecant is in the basement wouldn't allow us to get tangent. Okay.
Well, isn't it like, well,
So, looks like we're stuck. Some extremely clever person, I don't know who, tried this.
Too many clever people.
There are those, that's
Also,
like the
this is
history of
clever people
mathematics.
do
Like,
Weird stuff.
everybody who's like somebody named after something, it's somebody who just happened to have a burst of cleverness, like in the middle of nowhere. I mean, they were brilliant, don't get me wrong, but there's a lot of luck involved. Where you're just, just playing with this and saying, "Waha, look what I just found." And then, you get something named after you. So, maybe it'll happen to you. Somebody thought to do this. Now, this seems like you figure, yeah, okay, I'm glad that amused you, but what possible good did that do? Well, this is a product of 2 functions. They do simplify, but pretend they don't. Integration by parts could work, because we've used integration by parts with product integrals too. What would you use? This is actually kind of funny, but what would you choose as u and what would you choose as dv? There's actually not a heck of a lot of mystery here. Yeah, well, gee, I'll do sine of x for this one, and I'll do sine of x for the other one. Sine of x dx for the other one. And then what's du?
Cosine.
Cosine.
Yeah, sorry.
Of x, dx. And then what's v? Be careful.
Negative cosine.
Negative cosine of x. Well, it's a plus c, but we'll put that in. So the integration by parts is the integral of u dv is equal to uv minus the integral of v du. Now I'm going to clear the other side of the board off, which should give you a bit of foreshadowing as to what we're going to need to do. It's a little longer. It's not, it's nowhere near the monster I gave you the first time, but it is strange. I will caution you. Do you remember the first time you took the derivative of sine? What's the derivative of sine? Cosine. What's the derivative of cosine?
Negative sign.
Negative sine. What's the derivative of that?
Negative cosine.
Negative cosine. What's the derivative of that?
Sine.
Sine. And then it just keeps
Going.
cycling. I mentioned that for a mysterious reason that we'll find out in about 5 minutes. Do the integration by parts for me.
That would be sine of x times negative cosine of x.
So I'm going to do the whole thing. So the integral of, I'm just going to do it from the beginning. Sine of x dx is equal to, so uv, so what is it? What would that be?
Sine of x.
Sine of x times
Negative cosine.
negative cosine of x. How do you write that?
Negative
you
parentheses.
both are negative 1.
Yeah, pull the negative one out in front. The danger of doing sine of x times negative cosine of x is that people would write it as sine of x minus cosine of x by accident. So I'm going to put the negative in front. So negative sine of x cosine of x minus the integral of what?
Negative cosine of x.
Negative cosine
Times cosine.
times cosine, which is negative cosine squared of x dx. Ever right so far? All right. Now, these negatives cancel, which is kind of nice. In case you're wondering, you notice I don't usually keep writing the original problem. Why is Mr. Pac-Man wasting space? Come on, save some ink. Well, I'll show you in a minute. Plus the integral of cosine squared of x dx. So, okay, in order to finish this problem, I need to do this. Any bright ideas?
What looks like,
It looks a lot like the original problem.
So let's do it again.
Do it again.
no.
So a little, so how about this? I'll call this U1, DU1, DB1, B1. And then over here is, there's no reference to the music group, U2. This is really, I'm just gonna rewrite this cosine, cosine. Because that's pretty much where we're going. So, over here, the integral of, so let's say U2 dV2. What would you say they are?
Cosine of x.
Yeah, this is from, it'll look like a football player. Alright.
What did you post on it?
I'm just running out of room. If I had like a board twice as big, which I would, that would be my dream. I would just have a wall-to-wall board here. But whatever. I'll do cosine of x dx. So what's du2? Oh, negative sine of x dx. And then what's v2?
Sine.
Regular sine of x. Yeah. So, let's write this. Here's what we have so far. Integral of, I'll try and write it a little smaller. Integral of sine of x dx, that's the original, is equal to negative sine of x cosine of x plus, now do the integration by parts. U2 v2 minus the integral of v2 du2. U being minus the integral of v du. Go ahead and plug it in. What's u2?
Cosine of x.
Cosine of x. What's v2?
Oh. Sine of x, yeah.
It looks like cosine of x, sine of x. Okay. And I'm not absolutely sure. Yeah, that's good. Minus the integral of what?
Sine of x.
Sine of x, cosine of x? It's a v du.
Negative.
Yeah, so sine times negative sine.
Yeah.
What is that going to give you?
Negative sine squared.
Negative sine squared.
Did this go on forever? They cancel too.
Short answer is kind of no. This is dx.
Kinda no.
These will cancel plus plus. So the integral of, let me double check here. Actually, make some notes from when this really is.
How does this not go on forever? This
In
is
the first of,
Wouldn't that have to? Well,
yeah. Do the same thing you did before. It's like perpetually zero. It's weird.
blah, 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 blah. Huh. Yeah, I just want to make sure I didn't do anything stupid.
English and math conscious.
U dv, sine, yeah, and then du is cosine, dv, or v is negative cosine, that looks good. Oh! I went further than we had to. Would you think of me erasing one line if it saves us 20 minutes of work?
yeah.
Okay, good. I'm glad I scribbled that in. Man, that would have been, this would work eventually, but I want to show you something that's actually a little bit more sneaky. Do you remember what cosine squared is equal to using the master formula number 1?
Sine, well, sine,
squared is equal to,
Sine squared plus
Sine
one.
squared.
close,
Wait, one minus,
1 minus,
cosine, I mean sine.
1 minus sine squared. I'm just gonna rewrite that.
Could you have done that with
I'm gonna cancel. So, plus, could I have done it over there?
Yeah.
Yes, but it wouldn't have helped much. We would have had to use cosine.
Okay.
I'm doing this for a reason. This is going to be integral of 1 minus sine squared of x dx. Why on earth would I do that? Carry it down one more row. Here's the original. Integral of, I'm going to rewrite this as sine squared of x because it's getting a little long. Equals negative sine of x cosine of x.
That's because you erased the line.
Oh, did you? Okay. Plus, the integral of 1 dx plus the integral of negative sine of x squared of x dx. Everybody see what I just did? I just split this up. I'm going to move the negative in front. Do you see this?
Yeah.
It looks like the original problem just came back to haunt us.
Yeah.
I mean, normally you figure, oh boy, that's bad. Like, we're trapped forever. It's like, well, why don't I do this? Let's just start it over again. It's just gonna go forever. Here's where the sneaky part comes in. Turn off your calculus part of your brain. Turn on algebra.
Oh, yeah.
If I did this, A equals negative B
It's your Jonah. Yeah.
minus A.
Yeah, because you just add.
Could anybody do something that would make it a little easier?
Add.
Cancel the a's.
It won't cancel.
Cancel.
You'll get 2 of them.
Come on.
Now, does everybody agree that the entire point was to get what the integral of sine squared? That was the whole point. Let's just try this, just for giggles. Let's add the integral of sine squared to both sides. Tell me what you have so far. These cancel. 2 times the original mass that we don't know equals negative sine of x cosine of x. Can anybody do this in their head?
X.
X, yeah. And then plus. See?
Mm-hmm.
Watch this. Nothing up my sleeve. I'm going to divide everything by 2. And forgive me, c divided by 2 is just bigger c. You might be thinking, but we have to do this. We already have the answer.
Oh.
We're done.
Oh, snap.
Isn't that amazing? It's like, but I didn't do any integration. Well, yeah. it's like, poof, man, presto changeup. Is that legal? Yep. As long as I know what sine squared is equal to, I don't have to do it myself. So like they did it for me. And if it makes you feel better, we actually did do some integration a little bit. Yeah, little itty bitty ones. We never actually took the integral of sine squared, but it sort of gave us the answer anyway. So if, basically if you take the integration by parts and you do it over and over and over, and all of a sudden you get the original problem back, and then everybody starts panicking, says, oh no, it's an infinite loop. You're actually pretty close to being done. Use algebra to move that to the other side, and get only one of them by itself. Whatever the leftover the answer is, done. Yeah.
Did you need that extra U?
Uh,
Or was that, because you ended up just doing.
Oh, right. Yeah, actually, I do not.
Okay.
I do not. Darn, didn't have to do YouTube.
Bottom's so good.
Yeah, I know. Sorry, Edge.
Yeah, sorry, Ed.
Maybe next time. It's singers, I don't know if you're, okay. They're not my absolute favorite group either, but there's the, Bono was the name of the lead singer of U2, and Edge was
The
the
Edge.
nickname of another guy.
He's the lead guitar guy.
Yeah.
He's like super good.
What band is this?
He's very
U2.
U2, yeah.
And my dad's favorite band.
Still haven't found what I'm looking for.
Oh,
It was really big.
I know that.
Oh, okay.
That's good. I like
Any
this
questions on that? They're okay. Yeah, the Joshua Tree.
Yeah. Well, that's their older one.
Yeah, that's pretty old.
Yeah, it's like 80s.
So, well, so is it. So, cool.
I'd say 30 years old.
Any questions on that? Let me grab your worksheet.
What? Is that all we did today? Yeah, whatever, I'll take it.
No.
Am I supposed to get through?
Study for biology. Yeah.
Oh, yeah.
Well, I feel behind in every class. That's how they would.
Me too, but I really don't.
I mean, like, choosing baby pictures last night, I got on and it took me like 2 hours.
Oh, yikes. It's like 5 pictures.
I know, but it just like, I had like tons of pictures. I just,
How many baby pictures did you?
oh, I didn't choose. I mean, my mom ended up choosing them, but I didn't. Yeah. It was very nostalgic.
I know.
Yes.
I was like crying. I was like, oh, like,
Sorry, I had to separate a bunch
Oh, wow.
of history
Nice.
photocopies from
well,
mine.
it's like, I got a picture of me holding every one of my siblings when they were just born. Pretty cool.
Right.
Alright.
I was too young for this.
Okay, there are 4 problems total. These are all of the same structure as this. So,
Oh, there's 4 of them?
if you would like, I'd be willing to do one of them with you.
Yes, please.
This is
All right. One big one?
number 3. Let's do that.
Okay.
Oh, yeah.
It's, number 3 is similar to number 1. I'll keep that up there. Let's try it. You want to do number 3?
Yeah, this, yeah.
Okay. I don't think so. I am going to put e to the negative x as a
I thought it had like,
It's got to show on the keyboard.
Yeah.
Well, you're my first iPad got run over by a car.
Yeah.
yeah, that was
Yeah.
fun.
It was still a mess. That's supposed to survive a fall of like 8 feet.
Whoa.
I'm not testing.
Let's try it.
No. No.
Oh my gosh.
So this, a product integral should tell you integration by parts. Unless there's some sort of creative substitution, which I don't think so. If you have 2 functions that are not closely related to each other, like if this were, I don't know, sine times cosecant, they simplify. Or if you want to do sine and cosine, that's u and du. That's easy. That's a regular substitution. But if you have 2 things that are not related to each other, integration by parts should work. So u dv.
So we don't know which one's which.
So yeah, it's a good question. There's some argument for both. So which one do you think might work?
Let's go dv as cosine.
Okay.
Maybe.
And then u is equal to
Sine.
e to the negative x.
No, yeah,
So what's du?
it would just be e to the, or negative e to the negative x?
Yeah, it's e to the negative x times negative 1 for the chain rule dx. So yeah, that would be negative 1 e to the negative x.
It sounds weird.
And then what's b?
Sine of x?
Yeah, it's not bad. So what's integration by parts again?
It's uv minus the derivative of integral of v du.
A BDU. And I'm deliberately going to write the first part again. E to the negative x cosine of x dx is equal to u v minus integral of v du. Let's try it. Again, the reason I keep writing the original part is that in order to work this trick, I need an equation. I need 2 sides. So So u is e to the negative x. V is sine of x. Now this is no longer an integral, you don't have to do that, anything of that. Minus the integral of what? Times. Yeah, sine of x times negative 1 e to the negative x dx. Let's just simplify that. E to the negative x cosine of x dx equals e to the negative x sine of x. And you notice there's a minus here? Pull it out in front and it'll cancel. Plus the integral of what? Get it right in order. E to the negative x sine of x dx. Now these don't match, unfortunately. So this is one where we actually will have to do integration by parts one more time. Let's do it off to the side. It kind of depends on how your brain is wired, but I like using U1, V1, U2, V2 to keep them separate. Some people say, it's for wimps. And they just go off to the side and do another U and another dV. Completely up to you. Just make sure you don't get the two confused. So I'm going to do, so this part here is going to be integration by parts, no pun intended. So U2 dV2. What would you recommend? Same thing except for sine. So U is, that sounds good. So e to the negative x, and this will be sine of x dx. Try it. What's du2?
Same thing.
Yeah. So basically negative e to the negative x. Negative 1 e to the negative x. And then this thing is what? A little different. What's the integral of sine?
Negative cosine.
Negative cosine of x. So let's try this integration by parts. I have to write the entire thing. It's a little tedious.
We're gonna get the same thing.
Equals e to the negative x sine of x plus what? Do the integration by parts. UV. Didn't I simplify that some way? There's a negative in there. So, yeah, negative 1 e to the, so u times v.
Negative 1 cosine of x times e to the negative x.
Yeah, e to the negative x cosine of x. Oops, let me move this over a little further. Okay. Minus the integral of what?
That's the integral of negative cosine of x
Times
negative e to the x.
negative e to the x. So what's negative cosine of x times negative 1 e to the x?
Say that again? What's what?
What's this times this?
Oh. Cosine of x e to the negative x?
Yeah, I'll put the e to the negative x in front.
Yeah, e to the x, sorry.
And, oops, I forgot the dx.
So you can add it on both sides?
Do you notice something? The original problem came back to haunt us. But lest we panic, add that haunting problem to both sides. That's a horrible life metaphor, but when something's haunting you, do it everywhere. E to the x, cosine of x, dx. And then what does that give you? Over here. 2 original haunting integral. Cosine of x, dx. And what's left over? E to the negative x, sine of x. Yep. Divide by 2. Divide by 2. Cancel. Get it down.
The writing is the worst part.
I tell you, you're not kidding. It takes a lot of room.
Besides that,
That's why you get a lot of room. Does that make sense? That's all you need. The rest is yours. Enjoy, or good luck, or both. Call me if you get stuck. Let me see. Do a little caution here. Do you notice that number 2 is not cosine of x times ln of x? It's cosine of ln of x.
What the heck?
You might want to try a regular substitution first. See what happens. Actually, tell you what, not meaning to be a total Santa Claus, scratch off number 2, we'll do that together. We'll do that tomorrow. I don't scratch it off permanently, but
Right.
put a little skip or something. That I think we better do together. That would be a little. Alrighty. Enjoy it. I accept everything. I'll enjoy it twice. And yes, and video is still going on. Okay, well, I hope you enjoyed our show, Ella. So take care, God bless wherever you are, and see ya. And I'll email this stuff to you.